Hey guys, welcome to 13.3. Wait, I think it's 13.3. I should probably double check. Yes, no, it's not. It's 13.4. We're going to talk about, in 13.4, we're going to talk about pH and pOH calculations. And so let's start talking about just the pH scale. In one of my earlier videos, I mentioned that the pH scale, what it stands for, what it tells us is the concentration or the molarity of hydrogen ions in solution. Okay, so it measures the amount of H plus ions that are inside of a solution. Okay, and so usually the concentration of hydrogen ions is written in scientific notation. And the reason why it's written in scientific notation is because the concentration is usually a really, really small number. So what I wrote here for you would be kind of an example of what a concentration number might look like. It'll usually be, a number. It could be any number. I wrote 2, but it could be any number. And then it'll be times 10 2. And then the power or the exponent will always be a negative number because concentrations are really, really small numbers. So I want you to, for a second, I just want you to look at this scale right here. Notice how each number here is being multiplied by a negative exponent, and the negative exponent is getting bigger as we go to the right. So what happens to the numbers, the size of the numbers, as they're getting as their exponents are getting larger? They're negatively getting larger. So over here we have times 10 to the negative 1 power, but over here we have times 10 to the negative 14. So you should know, based on your knowledge of scientific notation, that 10 to the negative 14th power is a much smaller number than 10 to the negative 1 power. So any concentration of hydrogen ions that you have should fit somewhere on this scale. Okay, so for example, 2 times 10 to the negative 5 will be somewhere around this part, okay, because it's being multiplied by 10 to the negative 5, all right? So what I want you to understand is that over here we have smaller concentrations of H plus ions because the negative exponent is bigger. And then on this side, we have larger concentrations of H plus ions, okay, because our negative exponent is a smaller number. So we have more H plus on the left and less H plus on the right, okay? pH, what does pH actually stand for? Well, technically, like I said, pH is a measure of concentration, but probably a better explanation is that pH is the negative exponent of the hydrogen concentration. So if our H plus concentration was any number times 10 to the negative 1, the pH would be very close to negative 1. And so any concentration that has something times 10 to the negative 1 is going to have a pH that's close to the number 1, okay? And the reason why I'm not saying the pH is exactly 1 is because if your concentration is 1.0, and then with this ending, times 10 to the negative 1, that's when your pH is exactly 1, okay? But what if you don't have 1.0? What if you have another number like 2.5 times 10 to the negative 1? Well, that's where we have to estimate, okay? So here we can estimate that our pH will be around 1, but we don't know exactly what the pH is because this number right here isn't 1.0, okay? So let's go back, and I want to talk to you a little bit about acids and bases on this scale. So this chart shows you that anything to the left of 7 is acidic, anything to the right of 7 is basic, and anything right around the 7 period is neutral. So I'm going to give you exact numbers. We're going to say that anything that is neutral is going to be between 7 and 8, okay? And then acids, we're going to split into 2 groups. We're going to split into strong acids and weak acids, okay? And so weak acids are going to be anything between 3 and 6. That's going to be a weak acid. Anything between 0 and 3 will be our strong acids. Bases, we're going to split up the same way into strong and weak. Weak bases are going to be between 8 and 11. And then strong acids are going to be found between 11 and 14. Okay, so we're going to use those numbers. And it makes sense if we think about this, that the strong acid right here has higher numbers larger H plus ions, right? Because the more H plus you have, the stronger the acid you have. But over here, next to our strong bases over here, we have 10 to the negative 11, the negative 12, the negative 13, the negative 14. So those are smaller H plus ions. When we have fewer H plus ions in solution, then we don't have an acid and we end up having a base. And that's because we kind of go back to this teeter-totter. Okay, on this side, if I showed a teeter-totter, I would show my H plus ions are low in the solution, okay? So if my H plus ions are low, what has to be high? Well, the only other ion we've been talking about is OH. So when OH is high, H plus is low. Same thing could be said over here. It's just going to go the opposite way. When our H plus ions are high, like they are on the left side of the scale, okay, our OH ions will be low. And so what I've shown you down here, if you look at this scale down here, this is called the the pOH scale. The pOH scale, notice these numbers here are opposite of what they were in the pH scale, okay? And so I'm going to write down the actual numbers for the pOH. So look at how the pOH numbers are opposite of the pH numbers. That's because when the hydrogen ion concentration is high, so let's look at this one right here. 10 to the negative 1 power is a larger number, okay, than 10 to the negative 14. So when you have 10 to the negative 1 concentration of H+, you also have 10 to the negative 13. That's a very small number of OH ions, okay? So you see, when you have a larger H's, we have lower OH's. Let's look here in the middle. When I have 10 to the negative 7 of H ions, which is a neutral, I also have 10 to the negative 7 of OH ions. So these are balanced. This would be when my teeter-totter is exactly balanced, like this. Okay. When my pH values are small, when they're 10 to the negative 14, my OH values are high. Okay, they're at 1 or times 10 to the 0, so it's a much higher number. And so these pOH values, remember, these represent the negative exponents, okay? So these values are exactly opposite of the pH values, okay? So we come up with a rule based on looking at these two scales that the pH value plus the pOH value will always equal to this total scale number, which is 14. Okay, so let's solve these few problems over here in this box. I've given you the pH values, and I want to know the subsequent pOH values, okay? So going with our formula that I mentioned in the other side is that pH plus pOH should equal 14 together. If it's 7 plus, what is my pOH that will give me 14? Well, all I have to do is do 14 minus 7, and I'll know that my answer for pOH here is 7.0, okay? And then I'll do the same thing here. 2.4 is my pH. What is my pOH to equal 14? It's always out of 14. So if you don't know that off the top of your head, you can just like plug it in the calculator, 14 minus 2.4, and you'll get, 11.6. And same thing here. I've given you pH. How do you find pOH? You just are going to subtract. And I didn't give you any of the opposite, like I didn't give you pOH and ask for pH, but it works the same way. You just always subtract by 14 to find the one that you're missing. So something I want you to think about is can you determine if something's an acid or base based on these numbers? Well, remember what these numbers stand for. These numbers are all negative exponents, okay? So basically, this problem is saying that the pH value is 10 to the negative 7.0. Well, it's around that. And the pOH value is 10 to the negative 7.0. So this is H, and this is OH. So these numbers are the same, right? So they have same concentration, which means this is neutral. Let's do another problem. Let's do 2.4. So that means that pH is a 10 to the negative 2.4, okay? And then the pOH is 10 to the negative 11.6. Which one's a bigger number? This is going to end up being a larger number than this one because the negative exponent is, it's more negative. So this is kind of the 10 to the negative 2.4 is the least negative of the two numbers. So that means we have higher hydrogen concentration than we have pOH concentration. So we know it's going to be acidic. Now, if we want to know whether it's a strong acid or a weak acid, we could go back to my pH scale that I drew earlier, and we could see that this number, since it's between 0 and 3, it's considered a strong acid. Okay. All right, so now let's look at the last one. Here we have 10 to the negative 11.32, and then 10 to the negative 2.68. Whoops. So this has more OHs, right, than we have H's. So it's basic. If we want to know if it's a strong acid or a strong base, we always look at the pH number, and it's between 11 and 14, which means it is a strong base. All right, I want to show you a set of formulas that will help us doing a couple other problems. We just talked about how you can get 2 pOH or you can get 2 pH by just using this formula. You can find the opposite number because they'll always add together to equal 14, okay? And I kind of briefly talked about how to get your concentration if you're given pH or pOH. Remember I said you're going to just do 10 to the negative of whatever the pOH was, and then that will give you your hydroxide concentration. And then 10 to the negative pH will give you your hydrogen concentration. Okay, so let me do the opposite. Let's say I give you concentration. Say I gave you H concentration or I gave you OH concentration, and I want you to go to pH or pOH. There's not an easy way necessarily to do that, to remember this, but you just kind of have to memorize it. You'll do the negative, and you'll hit the log button on your calculator, okay? And the log button is found right here. And then it'll show you a parentheses. And so in the parentheses, you just need to type out whatever the OH concentration was that was given to you in the problem. And then close your parentheses. Same thing if you're trying to go to pH. You do negative log of the hydrogen concentration, close parentheses, and then you're good to go. So let's practice some of those together. It's a lot easier to practice if you have your calculator with you. Okay, I'm going to do one of each of these problems. So in this first problem, it says 1.0 times 10 to the negative 3, and I'm in the concentration. I want to go to pH, and so I have to do negative log of my concentration, which is 1.0 times 10 to the negative third, which, by the way, guys, what is pH? pH is the negative exponent, right? It's the negative exponent. So I should know, because this is 1.0, I should know that my pH is going to be 3. I don't even have to solve the problem. I should know that. The only way I know that is because anytime your number is 1.0, the pH is going to be the exponent, okay? If your number is anything other than 1.0, like these bottom two, then you actually have to plug it in the calculator, okay? Let's do this problem right here. To find I'm in OH concentration. To find pOH, you just do negative log, and you're going to put this number into your calculator, times 10 to the negative 11, close parentheses. So I'm going to do negative log, like this, and then I put 5.43, okay, and then you're going to do times 10, and press your exponent button, and then you can do negative 11. And then to get away, you see how I'm all the way up in my parentheses? To get back down, you just press the side arrow, and then you come down, and you close your parentheses. And so my answer is 10.27. Make sure you round and go to your hundredths place, and that's my pOH. So we have 2 more problems to practice, okay? And these problems, I'm giving you pH, and I want you to find the concentration. So you just do, not negative, just do 10 to the negative of the pH to find your answer. Same thing here, 10 to the negative of the pOH to find your answer. The hardest part is remembering that this number here is going to be molarity of my hydrogen concentration, whereas this answer is going to be molarity of my OH concentration, okay? If you're given pOH, then you find OH concentration. If you're given H, then you're finding pH concentration, okay? And then remember, anytime you're doing concentration, you have to put it into standard notation. So in my calculator, this came out as 0.01, but I have to rewrite it as 1.0 times 10 to the, and I moved it twice, so it's negative 2. My 2's are coming out weird on this, sorry. And then this one, I do 10 to the negative 7.2. And this one, it's already given to me in notation, which is great. Anytime you see the E, that means times 10. So it says times 10 to the negative 8th, and I am done with pH and pOH. Don't forget, guys, the most important thing about chemistry is to keep it trill. So just keeping it trill.